Hello guys, today I want to show you how to test your Android apps in terms of process and life cycle. So the first thing to test is process def restore, and the second thing is background kill caused by memory pressure. So let's move on to the first thing. I launched my simple app, which is just a simple app with search screen to display things from repository based on the query I typed in. And this is the view model, very simple, with query, results, and methods to update and search. So let's say I type something in, like Android, I click search, and this is a delay to simulate a network call. And as you can see, we see three things. So now I go to the background, I relaunch my app, and as you can see, everything is in here. But now let's move to the settings to turn on a thing called Don't Keep Activities, which is from developer options. And now we will be simulating when Android kill our app in the background. So let's say I have a very bad phone with very low memory, so that my app will be killed when I go to the background. So I relaunched my app, I type again something, I click search. Okay, I need to wait a little bit. Okay, at the end you can see everything is working. I go to the background. Now Android decided to kill my app because I have a very low memory. So I relaunch my app from background, of course. So as you can see, my app is in here. And as you can see, the state has not been restored. And why? It's because we store our variables in a memory, but our Android app has been killed, so that memory. So what we need to do to save our memory across relaunches, we need to save our data in a more persistent way. So one of the best one is to use save state handle, which is an Android container to store our data in a bundle. So a bundle is a container to store data in a memory, but when when our app is killed, it stores in a memory disk. So instead of using default values like in here, for query it's just a simple empty string, and for results is an empty list, we want to use as a default value save state handle like this, and save state handle can be nullable, so we need to parse a default value anyway. So right now it's working like this. We save something to query, but when query is empty, the default value is save state handle query, which is a persistent thing. But when save state handle will be empty, the default value will be displayed. And we do the same for a result. And we need to specify default value for this one too. And now we need to update save state handle, because right here we only read those things from the save state handle, but now we need to save those things. So in here we save every time we update our query, it's saved in save state handle. And we do the same for search. And right now we read and save our state. So right now let's relaunch our app. Okay, we wait. Okay, and now we type something, we click search. Okay, and we go to the background, and right now our save state handle. Oh, I can show you even that our app is recreated. So we go to logcat. Okay, we launch our app, and as you can see, our app has been recreated with onCreate, and the state has been saved in saved state handle. So this is the first thing. Now I want to show you the second thing, which is background kill caused by memory pressure. So in Android there is a thing called low memory kill, which is a daemon. A daemon is a process in Android which manage access to memory, so that when our memory is very low, low memory kill will kill Android apps that uses the most resources. So low memory kill, based on some metrics, decide which app to kill. And now I want to show you why it's so important to optimize your Android apps in resources. So I created a heavy in resources bitmap that I want to display in here, and some callbacks to show you how app is recreated or not. So let's launch this app, and we will launch the second app, because I want to show you the difference between a very lightweight app and a heavy one in resources. So I run a logcat, I clear it. Okay, there is some errors. It's not a problem. Okay, I used the wrong phone because for this one example I want to use a low in memory phone, because it's very important to show you how this is working in an old phone, not a new one, because a new one can handle our errors, but it's the problem that is commonly encountered on low memory phones. So we launch our app. Okay, now we launch the second lightweight app. We need to wait a second. Okay, and now as you can see, the two of my apps has been created, so heavy one and the lightweight. So I now clear logcat, and as you can see, as I change between them, they are not recreated, but they are only restored. So on start and on resume are called in both cases. But now, what will happen if we, let's say, run the third app, like for example Chrome? Okay, we wait. Okay, something is loading. Very good. Okay, we wait for Chrome to load, of course. Okay, and now let's check our apps. First, second app. Okay, very good. The second app has been restored, because on start and on resume only has been triggered. And now let's check the first heavy in memory app. And yeah, exactly. And as you can see, low memory kill killed my first heavy in memory resources app, because it used too much resources. So yeah, That's how low memory kill is working. So it's very important to optimize your apps on low memory phones to not encounter those things. But I won't be showing today how to optimize apps, because today I wanted to show you more Android, more tester perspective than an Android developer wants. So yeah, thank you guys for watching this video. I hope it was helpful for you, and like and subscribe, and see you soon.